Morning, everyone. Welcome to Dyslexia and Literacy, Oral Language Connections to Reading and Writing. I am Joan Mealy McCarthy, and I will be your moderator for the day. I've been working with Will Baker and the Dyslexia Foundation for several years to design these one-day conferences to bring science to practitioners, to truly make this effort a research practice, one for children who struggle with reading and literacy. My daily work is as executive director of the Summit School in Edgewater, Maryland, just outside of Annapolis. And I must tell you that my staff and I benefit all the time from the work of the foundation. I want to welcome educators and parents and sponsor schools. Typically, we would be gathered together in person in a beautiful auditorium, and we would be also live streaming all over the country. But it's a different day and time right now, and we are resilient, so we are all gathered on the grid. But we are very excited to be here and very grateful for MGH Institute to be hosting us with this virtual webinar. I hope that we have on the grid parents of children who struggle with reading, and educators and speech language pathologists, psychologists and social workers, and school administrators and medical practitioners. There is something in this conference from anyone who works with or has any connection to children who struggle with literacy. I'm so honored to see such a diversity of people here gathered just for the sole purpose of helping children. And the fact that you are here says that you understand our job is to do whatever it takes to help children become literate and to take their place in the world. And the need for us to do something is compelling, it's urgent. TDF hopes that today's experience will help each of you help children who struggle academically, even if it's one child at a time. Each year, we cover a topic that's relevant to educators and families and that is cutting edge in nature. We want our participants not only to learn something new, but to begin to think about what they know in an expanded way. That's why we present the neuroscience to set up the day, followed by the strong research that will support the practical application discussed in the afternoon. Today's conference is made possible, as I mentioned, by the Dyslexia Foundation, founded by Will Baker, a very smart, dedicated adult who has dyslexia. He founded this organization to help teachers and families help children learn how to read so they won't struggle in school the way he did. TDF is a nonprofit organization and depends upon member dues and participation in these events. Today, on behalf of Will, I would like to thank Dr. Tiffany Hogan and her research lab manager at MGH Institute, Mary Rasner, for partnering with us and hosting this conference virtually. I also want to recognize Rachel Norton, a graduate student in speech language pathology at MGH Institute, for helping with the administrative efforts for today. And I would also like to thank Lauren Jones, who's the executive assistant at the Southport School, for organizational and administrative support to make this day happen. And finally, I would like to thank our sponsors who partner with the Dyslexia Foundation so that these one-day conferences can be a reality. Dr. Culotta is a board-certified neuropsychologist and president of Neurobehavioral Associates in Columbia, Maryland. For over 20 years, Neurobehavioral Associates has served children and adolescents with learning, attention, chronic medical, and neurodevelopmental differences through neuropsychological assessment and consultations. Dr. Culotta has served as the director of neuropsychology in the neurosurgery division of the University of Maryland's R. Adams Cowley Shock Trauma Center. His clinical and research interests include disorders of executive functioning, dyslexia, autism spectrum disorders, and traumatic brain injury. Dr. Culotta serves on the board of several academic institutions and supervises the clinical and research training of graduate students. You are in for a treat. Dr. Culotta, thank you so much for speaking with us today.
Okay, let's see how the transition goes. Good morning, folks. How are you? I hope I'm coming through. Welcome to my office in Columbia, Maryland. This is not Boston, unfortunately. Before I start, let me take a moment and thank Will Baker and Joan Mealy McCarthy and the staff of TDF for inviting me to present, as well as the staff at Massachusetts General, Tiffany, Maura, and Lauren. It's a real pleasure to present with so many talented and acclaimed communication scientists. My wife sometimes says that when I'm around her friends, I make them nervous because I'm a psychologist and they think I might be analyzing them. Well, let me tell you what makes a neuropsychologist nervous. Communication scientists, a really wonderful group. I had a great colleague in Baltimore for years, Dr. Linda Spencer, and I used to love going to IEP meetings with Linda because I would listen to her present results from an evaluation, and she would discuss working memory, executive functions, reading and writing, and I always felt it was a bit of a mini lecture, so I always appreciated that. I really enjoyed Lori's talk. Lori, the model of the immune system, the FPN as the immune system of the mind, I think is wonderful. I think, first of all, it's gender neutral. We've had too many models of executive functions that include conductors and colonels and CEOs, and they all seem to be men wearing uniforms. So you may have stumbled onto something new and unique here. My talk is going to be a bit broader, and I should share my screen because I learned that from Lori. So let me do that now. Okay. Okay. Do I have slides up? Tiffany, do I have a slide up there?
Yep, it looks fantastic.
Okay, and I'm going to go to presenter view on mine, but are you seeing the entire slide before I start?
Yep, I'm seeing the entire slide. It looks great.
Okay, great. All right, so off we go. This talk will be a little bit broader and a little more general and a little more in terms of the breadth and depth of executive functions, the development of executive functions, and a little bit about executive dysfunction, because that's sort of what brings us all here. It's the context of executive dysfunctions in our learners. I thought about spending just an hour on statistical properties of neuropsychological tests, but I didn't think that was a great idea. We will be spending a good bit of time on assessment, mainly the problem of assessment, because executive functions are difficult to assess. I'll touch a little bit on ADHD and a little bit on models. I'm going to begin with Phineas Gage. Now, no neuropsychologist talks about, I'll get that done quickly, executive functions without talking about Gage. I won't spend a lot of time on Gage because many of you are probably familiar with it, but what I think is interesting is how long it took for us to understand that the brain, and particularly the frontal cortices, had something to do with how we behave, how we think and feel and guide and direct ourselves. And I think that's really relevant when it comes to reading because as we all know, reading is in the brain, but that is not necessarily universally accepted. And I think we still have some distance to go to put reading in the brain, as well as a number of other characteristics. So if you don't remember, it was 1848. Gage was a 25-year-old manager on the railroad, laying tracks in Vermont, when he had put some dynamite into a hole, and a coworker was supposed to put some sand in. Well, he thought the coworker had put the sand in. He banged his rod down, and the rod sparked the dynamite, and the rod flew through his brain. So what happened? Look at my direction down here. So Phineas went from a conscientious, efficient, well-behaved, and executing all the plans of operations, suggesting intact executive functions, to a rather irreverent, indulgent, profane, capricious individual. And Harlow, who originally saw him, said that this equilibrium between intellect and animal propensities had been destroyed. He was no longer Gage. And for those of you who've worked in the brain injury field, you know that many times what you hear from the family of TBI survivors is, he's no longer my husband, he's no longer who he was. So there's something uniquely human about executive functions and their regional localization in the frontal lobes that sort of makes us who we are. I think Gage let us know that self-regulation processes were located primarily in this region, that these regions served the capacity for judgment and decision-making. If you don't know, Gage ended up in South America on a horse farm. He died at a young age. I think he was 38 in San Francisco. His skull was preserved and eventually ended up, I believe, in Boston at Harvard. So an interesting guy. I'm going to talk a little bit about a number of elements of executive functions. And you'll find that almost all models, and Lori alluded to a few of the more recent models, almost all models include some element of attention, the capacity for control, flexibility, task initiation, planning, and organization. We know that in severe deficits, people can fail to be aware of themselves. Most major psychiatric disorders, such as schizophrenia or personality disorder, are characterized by a deficit in self-awareness or agnosignosia, and that is a more extreme example. I have emotional regulation on the bottom. I think there are many in our field that feel that we should be including emotional regulation as a criteria, for example, in the DSM on executive function. I don't know when that'll happen, but I suspect it will at some time. So briefly regarding models, I'm not going to take the time to walk through all of these, but these are some of the researchers over the years that have offered models of executive functioning. Badley's had a lot to do with working memory. Stuss talked about supervisory attentional systems. Martha Dankla about initiation, inhibition, sustained attention, and shifting. Jerry Joy and Pete Isquith or Kentworthy, a more integrative function. And Russell Barkley more in self-regulation and inhibition. And Barkley drew a lot from Bronowski. So I'm going to briefly mention Bronowski, a mathematician and historian, and I think whose work is particularly relevant now because what he talked about was science in the role of our lives and science in the role of our world. And that may be a particularly important topic now. He described language certainly as a capacity for communication, but also the ability to reflect, to plan, to propose, to execute, and evaluate. And this ability to reflect required inhibition, a central aspect of executive functioning. As humans, differentiating us from other species, it allowed us to go backward, present, and forward in time. It allowed us to pull apart emotion and content in our messages. It allowed internalization of language. You know, it's always interesting to ask children when they recognize and hear the voice in their head and what that voice tells them and how they can use that voice to direct them. And then finally, the ability to create new structures with language and thought. For humans, this is unique. There is a bend near my home, and at that bend, there is frequently this time of year a dead deer, unfortunately. And it's as though the deer can't go back to the other deer and say, you know what? My uncle's been killed there. My cousin's been hit there. Aunt Judy got hit there. We need to be able to stop going to that curve. So as long as there are deer there, I will know that they have not transcended to our aspect of language. My last model of executive function is the Hertz model, rarely talked about. Hertz is interesting because they've been around for 100 years, and they've decided that you should only give a car to someone who's 25 years old, suggesting a model for neural maturation, and someone who has a credit card. In other words, they've demonstrated some responsibility. So this model's been around long before our first imaging study and suggests that these folks actuarially, through numbers, picked a model for maturation and executive function that seems to be borne out by our science. Okay. I'll get it right eventually. So I'm going to look at executive functions as unique, as served primarily by the frontal lobes, but also some cortical structures and parietal structures, as Lori had indicated. The conductor of the orchestra is a Goldberg's model. That's been around for a while, and that's often used in what people refer to as the ability to direct cognition and emotions. And then we'll look at this prolonged developmental phase of executive functions. It takes a long time to get there. And I wonder now if it's even becoming a little more prolonged. You know, I think about what my father, born in the early 30s, was expected to do at the age of 18, and then what I was expected at the age of 18, and now what my daughters are expected. And I feel like it's a little more prolonged. Okay. I'd also like to talk a little bit about the general nature of executive functions. Many times artists have an intuitive way of understanding our nature that precedes our science. So years ago, I was asked by Sally Smith to come down to the Lab School of Washington and do a talk to open their year to their faculty. And I got to DC kind of early and visited a exhibit at the Smithsonian on art and education. And I came across this painting, Snap the Whip by Winslow Homer, a well-known American artist. What I found interesting about the painting is that he characterized boys as kinesthetic. You'll notice they are in motion. Their feet are in the air. They're exploratory by nature, heading towards the small corner of the field in the lower left corner of the painting. They are social, arms connected. And the red schoolhouse to me represented control, executive control, be it a teacher, a parent, coach, an elder. And that the idea of absence of such control might allow strong to subjugate weak. It's a really interesting understanding, I think, of development, again, that precedes much of our science. Okay, so executive functions are certainly driven by genetics and sculpted by the environment. And that sculpting can go on for a long, long time. We do know that there are windows of opportunity for development that as they close, becomes harder to teach certain skills. If a boy doesn't learn to throw a ball by the age of 9 or 10, or a girl, he's going to have difficulty with the throw. We used to say, he throws like a girl. Now, that's a gender biased statement today, but it reflected the fact that many young girls didn't begin throwing balls until middle school. Now, I coached girls softball for about 13 years, and I can tell you, if you teach a girl to throw at 4 or 5, she will throw exactly like a boy, but that window closes. Fortunately, for executive functions, that window remains open for many, many years. That's a positive and a negative. The positive is you have time to continue to develop those skills. The downside is those skills are open to perturbation, injury, or development. I remember when I first moved to Baltimore, I had been to Fells Point, a place where you could have a few adult beverages. And I was coming home up Monument Avenue, and Lori probably knows the topography pretty well because it's near Kennedy. It was raining, it was dark, and Monument is a steep hill, and I was going up. Coming down on the other side was a man, maybe in his mid-20s, on a spider bike with no helmet, careening down the street. And I thought, that's probably an executive function issue right there. Unfortunately, on his handlebars sat a young boy, maybe 4 years old, in a similar white t-shirt with no helmet. And I sort of had an vision of the clash of genetics and environment at that point. Not sure what happened to him. I hope things turned out well. We'll get it eventually. Risk factors early on. So some of the more common risk factors to executive functions include premature birth. And these are often perfusion-related issues. The brain needs oxygen to continue to build oligodendrocytes and for synaptogenesis and arborization of neurons. In utero substance exposure is a risk factor. Traumatic brain injury, as I've just mentioned, certainly a risk factor. Early stress. You know, we think about trauma in terms of sometimes neglect, sometimes malnutrition, sometimes deprivation. All of these result in high levels of cortisol in the brain, which are fairly toxic for developing appropriate neural networks. And so we know that some of these early risk factors may predispose children to executive function difficulties much further down the road. Mark Ivelsacker, a communication scientist and brain injury specialist, used to talk about children who have brain injuries early in life, as though a pebble were dropped in the water. And he would note that the ripples would become larger the further away it would get from the pebble. The idea being that these deficits sometimes are not evident until skills and structures are called upon to exercise their job, control, judgment, reasoning, social cognition. The sculpting of executive functions begins in utero, but clearly in day of life one, when a mother holds her baby close and they begin to develop a rhythm for self-calming and a rhythm for self-regulation. Eventually, I'll get it. Maturation of the brain. So interesting part about the frontal lobes. They are the last aspect of our brain to develop outside the womb, probably 25, maybe 30, and maybe longer in some cases. They are the last structure to develop in the brain, in utero, and they're probably the newest phylogenetic structure to the brain. So it's sort of a new tool in many ways, just as reading is relative to walking. And we know now that this maturation continues for quite some time. A point to mention about that, using intellect or age as a proxy for maturity and neurodevelopmental maturity can be quite dangerous. I think of a case recently of a young man with an IQ well above 130 who had attended an elite school in the Baltimore, Washington region with severe executive function deficits, generally untreated. He was preparing to go to a top-tier college. We felt he wasn't ready. Parents felt he was. He went to college. So first he was late getting his housing application in. So he ended up living about a mile off campus with some international students whose English proficiency was not great. He never filed for accommodations through student disability services. He took too many credits and missed the drop date. And halfway through the semester, he really began playing video games and not going to class. He left with a 1.8. You certainly wouldn't have predicted that from his education, nor from his IQ, but certainly from his executive functions. So the role of executive functions can be quite significant for our adaptation really across our lifespans. One of these days. Last part on developing executive functions. I really like this. I saw this a few years ago. Sort of a way to rethink the adolescent brain. You know, we sometimes have presented the adolescent brain as not fully formed or not functioning appropriately or not well suited. Dobbs and colleagues suggested it is actually perfectly well suited, that the adolescent brain is adaptive and it has become a very effective mechanism for moving from the safety of our home to independence. It allows some risk-taking. It allows the maturation of emotional regulation, and it allows tremendous resiliency in adolescence. I remember a couple of years ago at a board meeting up at Penn State for something I was doing, and it was around 10:30 in the evening in November. The temperature was about 42, and I was walking from dinner with a couple of colleagues along College Avenue, and along came young boys, men, 18, 19, 20, in khaki shorts and T-shirts, and they didn't look cold. I mean, even their resiliency to temperature was remarkable. Okay, so I just can't get it. A couple of words on plasticity before we move into assessment issues. Plasticity is the brain's capacity to change with input from the environment as well as continued genetic input. The only comment I would say is beware of those tools advertised to boost plasticity or boost executive functioning. I don't know that we're there yet. Several meta-analytic studies have suggested small gains, have suggested that perhaps these gains are not well generalized or maintained in the classroom. So across the street from me is the Columbia Town Center Mall, and it has a marble store in it where you can go to different sections to improve your cognitive function. All right, challenges to executive functions, tasks that are novel, tasks that are more complex, things that need to be done quickly with speed, things that are emotionally stressful, things that will require planning or delayed responding. Let's see if I get it right this time. Yes. Jane Holmes-Bernstein, I loved her idea about executive functions in the classroom. By the fourth grade, the ramp up for executive functions is on the rise. We are now expecting kids to take the fundamental and foundational skills that they've learned and apply them to literary analysis, apply them to quantitative reasoning, apply them to writing. At the same time, we're reducing in many ways our structural supports, particularly as you transition to the 6th grade. So for many students with executive function weaknesses, that increased demand for autonomy, speed, organization, and planning can be really detrimental in the classroom. You know, some schools are providing a more explicit instruction in study skills, time management, and organization beginning in the 6th grade. I think that's a wonderful idea. I wish it were happening earlier. I remember my daughter bringing a 5th grade history textbook home, and she was asked to prepare, and she just didn't know what to do with the chapter. She didn't really understand chapter headings and sidebars and questions at the end. And so we really had to sort of help her learn those study skills. All right. I don't think we can talk about executive functions without spending a couple minutes on executive dysfunction, because that's often what we're confronting in our daily sort of work. Executive dysfunction is not simply a matter of low motivation. I really think we need to understand this as a biological issue. If we see it as a motivational issue, our intervention tends to be a little more moralistic and a little more judgmental. And I don't think we've reached a point in our world where we can fully appreciate that a student's initial struggles should begin with an analysis of skills, not an assessment of his motivation. Skills precede motivation. I'm 5'8", I have a 2-inch vertical leap. You can guess my motivation for basketball. Okay. I found this hanging in the Baltimore area a few years ago, and I think it gave me a sense for, you know, what is still a pretty prevalent model out there. This notion that struggling students are reluctant learners. You know, I would hope by now that's an anachronistic model, but this certainly didn't suggest it based on the title of this conference for Maryland school psychologists, which included, as you can see, pupil personnel workers, counselors, and a number of others. That model can be really detrimental to children struggling in school. I think for many, it's not so much that they become depressed or anxious, which certainly can occur, but they become demoralized about learning. And once a kid reaches that point, it's hard for him to recover, and it's hard to help him recover. All right, let's look at a couple of symptoms for executive dysfunction. I'm not going to use the DSM-5 symptoms, while they're certainly helpful, and there are predominant nosology for diagnosis. This is a slide Tom Baumgartner and I developed years ago. This idea that executive functions certainly include attention and forgetfulness, organization, the capacity to perceive the passage of time. How long do you think it's going to take you to finish that assignment? Oh, I think it'll take me about 30 minutes. 2.5 hours later, still working on the assignment. Get started, sustain attention, inhibit distraction, but also a capacity for self-awareness. Sometimes a hyperfocus, particularly on Minecraft and Roblox and video games. Sometimes difficulty regulating temper, a tendency to overreact to minor provocations, or a valence of reaction that's disproportional to the provocations. Impatience. One of the questions I ask almost all of the students that I see is, what percentage of your day is boring in school? When the kid hits 70%, we're probably, we need to be looking very closely at executive functions, because kids are asked to attend to tasks that are not inherently interesting to them much of the time. And that's clearly an executive function. Okay, backwards again. I thought I had it for a minute there. Genes and anatomy. I'm just going to go down to Stephen Pliska's thought. I really like this. He discusses the idea of a diaspora, that the phenotype, perhaps a combination of genes and allele, is responsible for this exploratory behavior, impulsivity, and the regulation of dopamine and norepinephrine. Pliska said that perhaps that phenotype was more likely to emigrate from other countries over the last 150 years. So who got on boats? Who came to the United States? And does that in any way relate to our higher prevalence rate versus, say, Japan or Germany or Italy or France that have much lower prevalence rates? Australia has a similar prevalence rate to ours. I've got a cruise, so I think I'm gonna skip these things here. Intervention's pretty straightforward. Choose your parents carefully. Get good genes, modify the brain, modify the environment. Okay, I'm going to move into assessments now. Any assessment for executive functions has to be broad-based because it's a broad category, and this is a broad set of skills. It should include assessments of multiple domains. It should include a good developmental history. Were there perturbations for development early on? It should include observational data, observation of the child in the setting, the use of observational standardized measures, and then, of course, a number of tests. And it should always include a differential diagnosis. If it's EF, why is it not something else? And if it's not EFD, or executive dysfunction, what else could it be? So here's the problem. If you haven't been in a psych testing lab recently, they're fairly quiet. There's very little extraneous noise. We provide structure by sitting directly with the student. We offer directions in a clear manner. Sometimes we're able to repeat them depending on the test. We offer built-in prompts and cues. So by nature, we're supplanting a considerable amount of executive control, almost a prosthesis in that setting. And it makes the standardized measurement in the psych lab difficult. Bourdon writes about ecological validity. Ecological validity has to do with whether or not our testing actually predicts behavior and function in the real world. How do assessments predict our performance? Okay, never going to get there. Classroom observation. I do a lot of observations in classroom. Now I know I'm seeing 1 of 180 days, and with COVID, there's actually now tools to observe kids online. I am at a loss to figure out what the validity of that can be because I don't have any normative base or sense of it. And after 30 years of practice, I really don't know what kids do online. My guess is it's very, very difficult for them right now. So why are we doing an observation? What is the purpose? Where are we doing it? Are we doing it in a classroom? Is it a core academic or is it a special? How large is the classroom? How busy is the classroom? I'm a little older now. When I go in classrooms, I find them a little bit overwhelming visually, to tell you the truth. What can't you see? Can you see planning? You really can't. I mean, you can see the behavioral output of what you think is a plan, but you really can't see planning. You can see energy, that's for sure. How are you documenting an observation? Are you just writing things down? Are you doing timed segments? Are you using a tool? And are you objective? That's a real big point, especially in the IEP process in public settings. By the way, can you tell my guy here? He's up on his shoe, his leg is bent, his hands are up. You can imagine him saying, pick me, pick me, pick me. It's funny, disinhibition and lack of inhibitory control tends to send kids to neuropsychologists at young ages. When I walk into my waiting room and there's a 6-year-old sitting there, he's frustrating somebody, a parent, a coach, a teacher. When I see a 9 or 10-year-old, well, now I'm thinking about organization and planning, reading comprehension and writing. When I see a 19-year-old, I know things didn't go particularly well for the transition. I'm keeping my eye on the time. Okay. So observational measures that are standardized. Child behavior checklist and the BASC are probably the 2 most commonly used. This is a big swipe at emotions and behavior. And they're, I think, necessary and very helpful, but they're not diagnostic. It's very hard and probably inappropriate to predicate a diagnosis on those. And then we have narrow band measures. The Brief 2, which is an excellent instrument looking at behavioral regulation, cognitive regulation, and emotional regulation, and the CP2, Neglieri and Goldstein, which we've been using that a bit more of. And most of these narrow measures allow some form of parent and teacher report or informant report, and the Brief has a nice preschool scale. Okay, it's not going to happen. Quantitative measures. These are the domains we're going to be looking at. Do all domains need to be impaired to make a conclusion about executive dysfunction? No, but we certainly have to hit a point where we feel a number of these areas we're seeing struggles in a youngster. Attention, the capacity for sustained attention, divided attention, these are all based upon a neurologic paradigm called go, no, go, which is if I give you this stimuli, you respond. If I give you that one, you don't respond. The IVA, TOVA, and CPT, some find helpful when looking at medicine effects. I think they're probably a necessary part of any assessment, laboratory assessment of ADHD. I wish we had distractor items built in where perhaps we had classroom noise, or maybe I just stand behind the child and tap him on the back with my pencil like the kid in the seat behind you might do. Again, looking at that ecological validity. Inhibitory control, most of our inhibitory control tests, the Stroop color word from DCAFs, are based upon a similar paradigm. The Stroop effect, J. Ridley Stroop, many, many years ago, we think actually came from Wilhelm Wundt, the father of psychology, Germany, kind of cool. But you look at a word like blue, and obviously we are programmed, our habituated responses to read that word would be to label the color. So that's green and yellow and black. And I'm not going to do too many of these because I might miss one, and then you'll have some clue about my executive functions. The DCAFs adds a fourth category where the word is put in a box and you have to switch from naming the color to naming the word. So that's very interesting. The statue on the NEPC2 requires a child to stand still as though he's holding a flag, eyes closed, and you cough and you knock and you provide some distractors and you see whether he moves, whether he opens his eyes. It's about a 60 to 75 second test, and for many youngsters, that's about the longest 75 seconds of their lives. Okay, again, keeping my eye on the time. Working memory. So working memory is the brain's ability to keep something in mind, an online representational memory, and use it for processing. Digit span, forward and backward, is a good measure of working memory. The picture span of the WIS-5, a visual element, good measure of working memory. The CVLT is a list learning task. There are 15 words presented over 5 trials that give us a learning curve, which is a positively decelerating curve. We have a distractor list, and then we have measures of short and long free and cued recall. All of that is very helpful in assessing working memory. Your speakers later today, Dr. Singer and Bashir, 2018 article, I think, on working memory and students with learning limitations. I think the first 2 words are what weight. That's what's stuck in my mind. Okay. Planning and organization. Planning and organization is a little trickier. The Ray complex figure test requires a youngster to copy a very complex geometric figure. There's no time limits on it. We look to see how the child approaches the test. The scoring is pretty tight. It requires some basis for visual construction as a prerequisite. Martha Denkler published an article years ago looking at tasks that were more or less executive. For example, if you were to compare the VMI, Visual Motor Integration Test, which is fairly structured, each item is in a block and becomes increasingly complex and you copy it, versus the Ray, which requires the child to implement a problem-solving procedure, the ability to pull apart those 2 tests would give us some idea of executive function. This is probably the same when we're looking at vocabulary versus verbal fluency and a number of measures. Tower tests are very helpful. I like the tower test on the DCAFs. These typically require a youngster to follow or replicate a model with a couple of rules. You can't put a big disk on top of a small disk, and you have to do it in the fewest moves. Sometimes planning and organization from the genetic standpoint is evident by the transition from my waiting room to my office. So parents come in the morning, they've got a bag, a laptop, 2 drinks, the kid's got some device, and then I go out and introduce myself, now with a mask, and I say hello, and I said, come on, let's go back to my office. And it's always interesting to see how folks gather their belongings or how many things they leave in the waiting room or in my office. That gives us a little bit of cue what we're dealing with. Okay, concept formation. Concept formation, has to do with the brain's capacity to develop a class with characteristics and use that to solve a problem or shift flexibly. Animal sorting on the NEPC-2. What the picture you see is the Wisconsin card sorting test. In this task, students are asked to match the card with one of the four, and they may match by the number of figures, by the color, or by the shape. You're given feedback, wrong or right, correct or incorrect. When you're incorrect a couple of times, it means that the category has shifted now to a different matching concept. And we look to see how long it takes you to catch up with that or whether you might perseverate on the old one. Very similar models for sorting and DCEFs. Matrix reasoning also to some extent in the shifting and flexibility. Many of the tasks that look at concept formation also require shifting, and many of the measures of executive functioning may tap 3 or 4 different elements of that. I like to shift flexibly from one data set, numbers to letters, and back again. Word generation tasks. The controller word generation task, Arthur Benton, University of Iowa. Students are given either a letter like FA or S or a category like animals or boys' names, for example, in DCEFs, and asked to generate under time conditions as quickly as they can and as many words as they can with some rules. No capital letters, no formal nouns. Any of you who've worked in brain injury know that the FAS typically yields 3 words first. I won't say what they are. The relationship of verbal fluency, and Lori talked a little bit about that in her studies to executive functioning. Dankler described that as an overlap zone in kids that have both reading and executive function issues. And we see a very high concurrence rate of fluency deficits, particularly letter word fluency, not as much category fluency. Higher order language skills, how do we measure them? Well, category fluency is very similar to letter word fluency. The student is again asked to retrieve words given a particular category. That's a semantic fluency task. There is a measure on the CVLT for semantic versus serial clustering. The 15 words on the CVLT can be grouped into 3 categories. And over time, efficient learners use the category as a cue to retrieve words. And so they begin giving you the categories 1, 2, and 3. Others tend to remember serially, and you'll see a primacy and recency effect. Folks with intact higher order language skills will use that semantic clustering. I think the gray is a fairly good measure of aspects of higher order language. Now, some of the comprehension questions are content and fact, but they also ask some inferring questions, inferring emotions to characters or motivations. So that can be helpful in teasing out aspects of higher order language skill. Okay, just can't get it. Other higher order language skills, proverbs on DCEFs. I'm trying to think of a good one from that one. Something about the ox. I don't remember the ox offhand, but it's a tough one. Similarities, certainly a relationship with higher order language skills. The test of problem solving too, the adolescent version. It's nice because it does tap a number of areas: inferences, solutions, problem solving, interpreting others' perspectives. It offers composite and global scores. But I have to tell you, we just don't use it as frequently as we used to. We don't feel that it has a lot of sensitivity. And maybe that goes back to that ecological validity point. We see children earn scores on that are fairly robust, and yet we see many, many behavioral indices and academic indications that they really struggle with problem solving. Sort of like the writing sample subtest of the Woodcock-Johnson. You're writing a single sentence, it to me never seems to correlate well with what a kid can do in the classroom. And I have a conspiracy theory, which is that the publishers of the Woodcock-Johnson and all the local school systems got together and decided to create a test that would prevent the identification of a specific learning disorder in written expression. Anyway, that's just my little conspiracy theory. I like this language. Springsteen fan. something totally unintelligible, grossly misconstrued by millions. Okay, let me wrap up. I've got a couple of minutes. It's not the test you use, but how you use the test. Good psychologists, neuropsychologists, psychoeducation specialists are using tests as a model to drive and investigate their hypotheses. And they are using the elements and requirements of the tests to interpret and understand. It's a bit of a process approach, but it also relies on inter-individual comparisons and intra-individual comparisons, as well as pathonomic signs. And I think when you've done enough of this stuff, you really figure out how to use a test best. Using a single measure, again, to rule in or rule out an executive dysfunction in a student, I think is clearly unwise and inaccurate. So quick summary. Executive functions have a long and protracted course of development, well into the third decade of our life. They're driven by genes and environment that allows a degree of plasticity and changeability. They're in integrated control processes. And I really like the idea of the FPN, Lori, that may be in our future in terms of an immune system as a model. It is a challenge to assess executive functions in the laboratory. They are inextricably intertwined with language and skill and language skills, and they're uniquely human. Last piece of artwork, Sistine Chapel. Many of you may have seen this, some of you may have not. This is Michelangelo's painting on the Sistine Chapel. Look at the shape of the robe around God. Look at the lack of touch between God and Adam and the location. So here's an interpretation of that picture. The borders correlate with the inner and outer surface of the brain. The hand doesn't touch Adam, almost as a synapse functions close. God's superimposed over the limbic system for motion, and the right hand extends through the prefrontal cortex, which may be the most uniquely human region. Michelangelo did a lot of cadaver work. It's always interesting how the sense of who we are and what we are can be understood sometimes through art and through the marriage of art and science. I'm going to stop at this point. I think I'm at my time, and let Joan or Tiffany take over. Thank you.
That was a great talk. This is Maura, by the way.
Hi,
Thanks
Maura.
so much.
Thank you.
And we do have time to go through a few of the questions folks have been asking. And what I'm going to do is read the ones that were upvoted the most in the question and answer.
Okay.
And the first one is, if a child already has a diagnosis of ADHD, does it make sense to still get them tested for EDF? And how would that affect the types of intervention that a school would offer?
Yeah, I really think it does, because the diagnosis of ADHD, first of all, we want to know how it's made. Was it in a pediatrician's office? Was it a Vanderbilt scale? And have we ruled out other potentially co-occurring conditions? And then what aspects of ADHD? What brings parents to pediatricians are often unruly behavior, children that are difficult to control. It's harder to see those aspects of executive functioning that affect cognitive regulation, language, and academics. So, I clearly think there's value in testing a youngster that has a diagnosis of ADHD that hasn't undergone a fuller assessment of those aspects of executive functioning.
That was really helpful. And I have to say that was a very popular question. So I know a lot of people were waiting to hear that.
Sure.
I'm going to kind of move down to the next one. We've got a few minutes because I think we have plenty of time for questions. So it's really interesting that you would observe or assess a child online. Can this kind of procedure be used for psychological testing or 3-year eligibility reeval?
We've been testing in the office for quite some time. We have double desks, we use screens, we use pointers instead of having children touch materials. We've laminated anything that can be laminated. We've switched gears. Instead of using the RAN-RAS, we use rapid naming from the CTOP. I'm not encouraged at this point about online testing, particularly with children. I think we have some measures for adults in the dementia categories that have been vetted and used, and there have been a number of professional presentations. But no, I'm not confident that teletesting is effective. And I'm very concerned about the transition to continuation of learning plans from an IEP. There are a couple of studies out there now that suggest that many of the elementary school students, and most specifically the special education students, are really not making gains and may well be regressing. So it's worrisome.
That definitely is very concerning, and it was great to hear your thoughts. I'm just going to keep moving down the list.
Sure.
People are really interested and have a lot to ask. Do you think there's any links between the ability to grow our executive functioning and the amount of screen time, particularly at an early age?
Yes, definitely. Unfortunately, digital technology has moved so quickly, traditional research has not been able to keep pace. Every time something's published via the American Academy of Pediatrics regarding screen time, it's almost outdated by the time it hits the journal. What we do know from imaging studies is that screen time seems to suppress prefrontal function, particularly in strategy-based or video games, and particularly in aggressive video games. So we have this suppression of the prefrontal cortex. We have some limbic activation. That is not a good neural signature for learning. So it's been very difficult for parents because the children haven't been able to go anywhere through COVID, and they've been spending hours and hours on screen, just as we are all today. And I think it's a difficult task. Our recommendations are generally an hour or less a day, and certainly not before bedtime, and to really control content that's age appropriate.
Thank you. The next one up is a very kind of different question. Is there a connection between seizure disorders in children and their executive function?
Yeah, the short answer is yes. I mean, seizure disorder recommends or indicates an anomaly in the brain. An abnormal electrical firing in the brain may be anatomically or neurochemically related. And seizures can be focal or they can be more generalized. And I think for any child with a seizure disorder, we should feel the need to rule out an executive dysfunction. In other words, that should be our starting point. And for those children whose seizures are left temporal, interference with learning and memory and the consolidation of newly learned material can be really disruptive. What we'll hear from teachers many times is he's just not retaining the skills. He had it yesterday. He didn't seem to hold on to it. There can be subtle seizures at night, slow wave spikes that may also interfere with consolidation.
So this is another question about kind of causal factors. So is executive function increasing in incidence? And do you think there is a direct correlation in increased use of legal and illegal drug use and alcohol among pregnant mothers?
That's a big one. Are executive function or dysfunction increasing? I don't know that it's increasing as a prevalence rate. I think we're more aware of what constitutes executive dysfunction. I can remember working in trauma, surgeons would often say, why are there so many young men with ADHD in my admitting area on a Saturday night? And if you look at males between 16 and 24 with executive function deficits, they tend to not always make the best decisions, which may put them in harm's way. So having the physician recognize that what got this kid in the car wreck or had him jump off the canoe into 2 feet of water or ended up in the wrong place at the wrong time were really a set of executive functions, and that we should characterize that as a brain-based deficit rather than bad judgment or immaturity. On the second issue, certainly substances such as alcohol and drugs impact children in utero. And I think I'll probably beg off on the rest of that. There are probably more qualified people to answer that question, but executive functions, given their protracted course of development and fragility in utero, would be suspected as a problematic in those cases.
All right, I'm going to read one more and then we'll go on break for a while. So the last question for this presentation that we'll ask is there any evidence that sound therapy has a positive effect on executive function?
I'm not aware of any. There are a lot of advertised treatments for neurodevelopmental issues in general and executive function in particular. I don't know that any of them have really reached a basis in research that we want to rely upon. I'm also aware that sometimes those interventions are sold to parents based on fear. You know, the implicit underlying question is, would you like to avoid putting your kid on medicine? Well, we can do this or we can do that. I think brain activity, obviously throughout our lifespan, is important and preservative of our brains. But at this point, I'm not sure that any of those therapies have reached the evidentiary level where we would recommend them regularly.
Thank you. Thanks for a great presentation and for answering all of those questions.